Thanks for that dance, Nicole. Well, hey, everybody. Welcome to the Weekly Space Hangout for Friday, November 7th, 2014. I'm Fraser, Cain, the publisher of Universe Today, and this week we have got a fairly large collection of the Weekly Space Hangout crew. Team, not crew. Crew is the community, team is the reporter. So, joining me first, we've got Dr. Brian Koberlein.
Hi.
Dr. Koberlein. We've got Mr. Morgan Rehnberg. Mr. Rehnberg.
Good to be here.
And we've got Dr. Nicole Gugliucci.
Hello.
Who is going to be the star of the show today because the coolest image of, I think, of 2014 just came out yesterday, and we're going to talk about it. So
Specifically requested screen on air, so there'll be screen on air.
Yeah.
As soon as I saw the picture, I went to see if somebody had taken it, and you'd beaten me to it.
Yeah.
I was like, oh man, I can't believe it.
Yeah, I know. So before we get too deep into this, we're going to give you an update on what's been happening with Spaceship Two since we were sort of covering the news last week. We're going to talk about what's happening with Antares. We're going to be talking about this picture, of course, from Alma. Gravitational lensing of binary black holes and a new idea on dark matter. Plus, we're going to include a bunch of stories from our good friends at the Weekly Space Hangout crew. So, let's get cracking. Now, oh, and by the way, you can always interact with us here on the Weekly Space Hangout. The best way to do that is to use the Q&A app, which I have enabled. Have I enabled it?
Yes.
Yes, I have. So, which I have enabled this week, and so you can use the Q&A app to ask us some questions, post any comments. Keep the chit chat down if possible, so that I can see the questions. If you want to just comment on the event page, that's probably the better way to do it.
They've been really good at that, and they've totally self-organized that.
I know. I love it. I love it.
And yeah, you guys rock.
And so just to sort of give another big plug to the WSH crew, this is the Weekly Space Hangout crew. This is the Google Plus community that has really sort of come to embrace this show that we do and be both fans and a real contribution. They are now the sort of third part to this whole show, and we really appreciate their all their involvement. So if you want to find them, just go to Google Plus, do a search for WSH Crew, and join that family. All right, well, let's get cracking. So let's start with an update on the big story, which was last week, which was the destruction of the Spaceship Two, and one of the pilots' lives lost their life. So Morgan, you've been following this story. What is the update?
Yeah, so I want to start by actually correcting the coverage that we've had so far. We've been referring to the craft that broke up as Spaceship Two, but that's actually the name for the class of spacecraft. The individual craft that broke up was the VSS Enterprise, and there's actually a second craft partially under construction, and that'll be the VSS Voyager. And I also want to start off by saying that everything we talk about is very preliminary. The National Transportation Safety Board of the United States estimates it could take up to a year to fully understand what happened during this accident. They haven't even interviewed the pilot yet, who's still in the hospital. But all of that being said, a picture is starting to emerge of what went wrong. And it's not what we thought maybe had gone wrong initially. If you remember back a week, this was the first flight of the Enterprise since they'd implemented this new engine designed to be more powerful and yet more fuel efficient at the same time. And lots of people speculated that a failure of this engine was likely responsible for the loss of the spacecraft. But that doesn't seem to be the case according to initial investigations. The engine seems to be more or less intact on the ground, as much as anything that hits the ground at Mach 1 can really be intact. And instead, it has to do with the re-entry system that seems to be the point of failure. In order to slow down from space to land, the Enterprise has this special system called feathering. And what it does basically is tilts its wings up. And this causes it to change its aerodynamic shape and basically brake more efficiently through the air. But shortly after the ship was released from its carrier plane, one of the pilots moved basically the lever to activate this feature into the arm position. not actually activating it, but making it possible to then activate with the press of a button. And then it seems as if that was inadvertently activated without any sort of human control, and this feathering system readjusted the position of the wings too soon, basically, in the flight. In fact, the spacecraft was going too slowly for it to have this aerodynamic shape, and the Enterprise basically experienced unexpected stress on its airframe, and it quickly broke apart and fell down to the ground.
So just to clarify, Morgan, so was it like I guess the pilot had put this into the arm position in that it would then be ready to go to shift into the aerodynamic feathering position when it had reached the apogee of its flight, but for some reason, instead of just preparing it, it actually disengaged it, and then when it was not at the right part of its trajectory.
Right. So there seems to be a couple of things that went wrong here. First, the arm position was not supposed to be activated at this point in the flight. The pilot should not have moved the lever into this position, as far as we know, at this point during the flight. But that action alone should not have caused any problems with the spacecraft. There was some sort of additional mechanical failure that then immediately deployed the feathering system when the lever was activated, as opposed to waiting for confirmation from the pilot. And I think this kind of bridges the whole issue that Virgin Galactic is encountering, which is they're trying to be halfway between air travel and spaceflight. And spaceflight is very risk-prone, very kind of close to the metal, if you will, in terms of how you work in terms of safety. Air travel is the opposite. I mean, airplanes are the safest mode of transportation on Earth, and the airline industry works using a system called two-fault protection. And that means that if a pilot makes an error and a mechanical fault occurs, nothing should go wrong. Basically, 3 things have to go wrong on an airplane in order for any sort of adverse event to occur. And of course, what we're seeing in this instance is that 2 things went wrong. A pilot made an error and a mechanical problem occurred, and yet that was enough to damage the spacecraft fatally. And so in order to, I think, convince people to continue to buy tickets to go on future Virgin Galactic flights, they need to think about how error tolerant is feasible for a craft of this kind.
And it feels like that is obviously it's a terrible tragedy, and the fact, it's been cast in this light that essentially people are dying so that rich people can have some fun, and that's I
don't think that's the right way to look at it.
Well, that is definitely the argument that is being held against Virgin Galactic, right? But then you could say that is air travel, that rich people are able to fly in airplanes across the world, and that the problem that Spaceship Two, or that the Enterprise suffered, is the kind of problem that gets caught, as you said, through the airline industry has these checklist processes, this quality control, that, as we had expected or suspected last week, that it was an engine problem with essentially very new, very complicated technology, that would be a much more intractable problem. And so I think that's why Branson has said, no, we're still on track. I'm going to be the first one to fly with my family. Tests continue, 2015. This is still going to happen.
Yeah, I think it's important to remember that one of the Wright brothers died testing one of the very first airplanes, and that wasn't so rich people could fly, and it wasn't a reason to stop developing air travel. Through tests and accidents like that, we've made air travel the safest way to travel in the world. And there's no reason to think that we can't move space travel in that direction. And accidents happen, and we have to take every possible precaution to prevent them and to keep them from happening again. But it's not a reason to just put the brakes on the whole operation.
Yeah. I see is there are plenty of social injustices in the world, and it's not like we're actively strapping, poor people to spacecraft and crashing it.
This person knew the risks. They volunteered for this sort of job.
There are plenty of other social inequalities you can be mad at.
Yeah. All right. Well, I think obviously this is going to be a story that's unfolding, and we'll be coming back to it probably many weeks into the future. So let's move on then to the big story, I think, which is that just broke yesterday. Is this amazing photograph of a protoplanetary disk? And so, do you want to dig up the story to it, Nicole? You talk, and I will dig up the picture. Okay?
Oh, but I want to show my version of the picture first.
Okay.
Because, as you guys know, over Hubble, because Alma got you. We've been trying to make this a meme for like 2 years now, and it's failed. But that's okay, because I can still use it anytime they put up an awesome image like this. So I'll like freak out.
So tell us what happened, and I will dig up a picture here.
Sure. So this is a picture from the Atacama Large Millimeter Submeter Array, or ALMA. This is an array of radio telescopes in the desert in Chile. The final array is going to have, I think, 64, 66 antennas in it. I got to visit back in March 2013 when they did the official inauguration and opening of the array. And this is the most sensitive and highest resolution we've ever had at this particular waveband, this millimeter, submillimeter wavelength. Some people see it as being between radio and infrared. Some people see it as being really high frequency radio. I have one friend that said if it's a dish, it's radio. Deal with it. So take that as you will. Anyway, Alma. So Alma. This is still part of the early testing phases of Alma. They made this gorgeous image of an exosolar system in the making. So we know that solar systems or exosolar systems form out of these disks, and that the planets, the planetesimals, as they're forming, clear out lanes or clear out these rings in the dust. And so that's what we're actually seeing. This is not. A lot of people saw this and thought it was an artist's conception. This is actually an image from the telescope. The way you get this high resolution is you put these telescopes, these radio dishes, in different spots on site. I think the longest baseline, let me make sure I'm correct on this, the longest baseline for this one was 15 kilometers, so that was the widest spacing between antennas. Mm-hmm. And you get the data from all the different antennas, and using some math, using Fourier transforms, if you know how that works, great. If not, don't worry about it. They make this map of the brightness and the region that they're looking at, and they got this so high resolution that you can actually see these lanes that are being carved out by the planets. The resolution in this image is 35 milli-arc seconds. So a couple ways to think about what the heck is a milli-arc second. If you put your finger out at arm's length, the width of that is about 1 degree. You chop your finger into 60 parts, you have arc minutes. You take one of those arc minutes and chop it into 60 more parts, you have an arc second. A milli-arc second is 1,000th of that. An easier way to think of it came from the NRO press release. It's the equivalent of seeing a penny from 110 kilometers away. So this is incredibly high spatial resolution. I saw some discussion on Twitter about whether or not there were spokes or other weird features, though I don't know what the actual sensitivity on this image is, and it's possible that the lumpiness is due to something that we call the beam pattern in interferometry, the way the image was made. So it's not clear how much of that lumpiness is part of the imaging artifacts, but those lanes in the disk are real and are being carved out by baby planets. So want to see a baby solar system form? Alma got you.
Now the image, and I'll keep it on the image because I just can't stop looking at it. It looks like the kind of image that would be produced by an infrared telescope, right? Mm-hmm. Something that a Spitzer or I guess a James Webb would be turning up. But this is more on the radio spectrum. So what is the radio turning up that maybe we wouldn't see in other wavelengths?
Well, the radio is, what the radio is doing is peering through the dust. So the dust blocks visible light and tends to give off infrared light. It's looking through that, looking past that to the actual system of the disk and the star, which is it's HL tau. And this is so it can peer through that. And I think it's the choice of color scheme is probably what reminds you of an infrared image in this case. That could be whatever they want it to be.
Right. If they'd made it purple, I would have thought it was from Chandra.
Right.
Okay.
Exactly. Exactly. The HL Tau is a classic example of a T Tauri star, which is a protostar that's forming surrounded by dust, so often obscured in optical, and you can see the dust itself in infrared. So this is going a little bit beyond that to the actual solar system formation.
Now we're just in the initial stages of essentially them doing their first shakedown, first test results as they're sort of testing out the whole experiment. I mean, what's going to be possible?
Well, you're going to see more of these. In fact, although people were surprised, I will be honest. Back when I was in grad school in Charlottesville, which is the head of National Radio Astronomy Observatory, one of the major partners of ALMA, they showed simulations like this and said, this is what ALMA will see. And some of us, I was one of them that laughed. Like, come on, really? You think you're going to get that good? Yeah, I take it back. I take it all back, ALMA. They were saying that they're going to see several systems like this. Also peering into the early universe and seeing luminous infrared galaxies. So we're seeing the birth of planets. We're also seeing the birth of stars. We'll be seeing the birth of galaxies early on in the universe. Those ultra-luminous infrared galaxies are going to show up bright in millimeter and submillimeter. So they'll be mapping that as well and getting high-resolution images of that as well. There's a whole, let's just say, metric butt-ton of science that is capable with ALMA. And they have open proposals, so they split some time amongst the partners, but there's also open time that pretty much anybody can propose for time on the telescope. Of course, you have to have a really competitive proposal. It's already oversubscribed 10-1, I think. So it's got a similar oversubscription rate as Hubble already.
And this is just gonna boost the demand even higher.
Yes. Yes.
Mm-hmm. Yeah.
Yeah.
Well, and it just shows you, I mean, in case you weren't sure, more telescope, more better.
More telescope, more better. I love that.
Yeah.
I'm going to make a bumper sticker.
Because I mean, there's the, James Webb is going to, I'm sure when we see those first images from James Webb, it's going to blow our minds. When we see the first images from like the 30-meter, the GMTs and the Magellans and the big telescopes, again, same thing. We're just won't be able to believe what we're seeing.
Like I said, I literally laughed when they showed a simulation of this image years ago of this is what we think we'll see with ALMA, and they did it. So rock on.
Yeah, and they're just getting started.
Yeah. Yep.
Awesome, amazing. All right, well, let's move on. That's good. You publicly apologized. I think at this point.
This is not the first time I've apologized. I apologized right after my visit too. I was like, guys, I'm sorry for all those years. I went blah 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 ALMA, sick of hearing about ALMA. Now that it's here, it's really pretty.
You know what? I got to agree that I think the name is maybe a little boring.
Really?
Yeah, ALMA. I think it just we report on it tons, right? A whole bunch of dishes set up in the desert of Chile, but now we're seeing it. So I think we need to change the name to the super awesome telescope array.
I believe ALMA is soul in Spanish. So not as boring as you think.
My Spanish is weak. All right, let's move on. Brian Koberlein, tell me about gravitational lensing of binary black holes.
Well, this is a paper that came out that calculates the gravitational lensing by binary black holes, which is really kind of different. We've seen computer simulations of gravitational lensing around a single black hole, but these are all generally a static, non-rotating black hole that has the kind of first perturbation over where the black hole actually is. And that's pretty straightforward. You can do that on your laptop. The equations are not that complicated, and it's all stationary, and it's one of those things you hand out students. This is different because of two reasons. One is you're including rotation, but the other one is that you're including two black holes. So you have two black holes that are orbiting each other and rotating, and then you have background light passing close to those black holes, and then how they're distorted. And the fascinating thing about this is how you have to calculate it out. This is not a static system. The black holes are rotating, but they're orbiting. So as the light comes in, the motion of the black holes themselves distort the light in different ways, because the light takes time to pass the black holes, and while it's passing the black holes are themselves moving. So they go ahead and do this and calculate. If you look at the actual paper, they've got a whole bunch of different examples in terms of equal mass and unequal mass black holes, whether they're rotating quickly or not rotating, and you get all of these distortion patterns, which is kind of fascinating to see. And it does come out of the same group that is working on a particular movie that it will remain unnamed, but it's a lot.
Why is this movie going to remain unnamed? What, do you think I'm in the pocket of Big Interstellar? Is that what you think? Just because I happen to participate in the live Interstellar Hangout 2 days ago and explain space-time warping to Anne Hathaway?
Yeah.
Is that what you think? I'm on their payroll now? I'm not.
Jealous. By the way, jealous.
I know. So good. It was awesome. I mean, the fact that they had me explain what a black hole is and then explain why light gets affected by a black hole, I thought I did okay. See, I am a sponge. I just listen to you guys, all of my doctorate friends, and then absorb all the knowledge and try to replicate it.
And then you get to go do the cool stuff.
Look at that monkey talking, that talking monkey. So, so this is cool, and so yeah, I mean, you see that that simulation, of course. Kip Thorne helped out with the simulation of the black hole for Interstellar, and so you're getting a hint of that distortion, that the light that's coming around and orbiting the black hole. But then they just took it 7 degrees harder, right? They made 2 black holes orbiting one another, and they're all rotating, and the whole system is rotating, and light just doesn't know what to do.
Right, and this is an interesting combination of the kind of traditional computer animation ray tracing effect and real computational physics. So it kind of straddles the two of them in the sense that they're using the ray tracing methods at the same time that they're using the traditional computational methods that you use with black holes. Very cool.
So I guess from a sort of, I mean, this is all in the modeling stage. Is this going to then give astronomers some observational astronomers some things that they can start looking for?
Possibly. I mean, most of these, the type of binary black holes that we would see would be largely obscured by dust. But I think simulating these not only helps us understand how to project general relativity, but if you had, for example, a strong radio source behind it, you could see how that radio source would be distorted, and then you could compare that with observations in the real world. And so it might be a way to see the type of brightening and darkening and redshift and blue shift patterns that you would see in something like a quasar signal, so that if you happen to have something in front of it, you could see what's going on.
Okay, so you could see a quasar, and you could see the way the light is coming from it, and you could know that quasar might actually be a binary pair of black holes and not just a single rotating black hole.
Right, something like that. But right now, this is just kind of being able to compute what this stuff actually looks like, which is a big achievement in and of itself.
That's it's really cool. Okay, so Morgan, why don't we go back and let's talk about the Antares disaster and what's going to happen now?
Yeah, so Antares, of course, is manufactured by Orbital Sciences, and they have a contract to deliver cargo to the space station. And in fact, they were trying to deliver cargo last week when this accident happened. And again, this is a preliminary investigation, but the accident seems to be traced back to a failure in one of the 2 engines on board the Antares. And these are engines that have a quite old design. Maybe even refurbished from engines that were first manufactured in Russia, and this has been sort of traced back to what the problem was. But Orbital is adamant that they are going to continue with the contract with NASA and fulfill all their obligations without any delay or additional cost to the space agency. And they've outlined a 2-step process for how they're going to do that. They don't have any more launches scheduled for 2014. In 2015, they're going to purchase other rockets from different companies and place their Cygnus capsules on top of those rockets. And they're highlighting the fact that the Cygnus is designed to be interoperable with a range of rockets, and that's allowing them the flexibility here to switch to a different provider when necessary. And while they're doing that, they're going to be prepping new rockets for the Antares. And this was always the plan all along, to put in a new sort of homegrown design engine for the Antares. But they're accelerating the pace with which they do this, and they plan to have these engines integrated with the Antares in time to begin launching Antares again in 2016. So they'll need 1 year of purchasing third-party rockets and placing their Cygnus capsule on top. And then in 2016, they'll have basically a new rocket that they can put their capsule on and begin launching again with their own entire system. And they claim this will be no additional cost to NASA, no delays in the launches, and only very slight changes to the manifest of the various launches. And so they're optimistic that they can fulfill every requirement of their contract, prove that they're flexible in the face of this incident, and move forward to be competitive in the future.
And they've got a lot to lose now. I mean, that I'm sure Elon Musk and SpaceX is just waiting to fill whatever delays in the schedule happen. And that's, I think, as we've, the rocket engines that they were using, these were the ones that were developed for the N1, the Soviet moon lander, the moon rocket. And these are things that have been used and tested since the 60s. This is with all this Soviet technology, the Progress, the Soyuz capsules, this stuff has been tested for decades and decades. So for them to say that don't worry about it, we're gonna build a whole new rocket and a new motor and just get right back to our schedule, that seems pretty ambitious, pretty aggressive, and I'm sure SpaceX is going to be like, good luck, and if you have any problems, we're here to take those capsules, and do you want to buy some rockets?
Yeah, they're definitely feeling pressure to keep up, because so far things have worked more or less flawlessly for SpaceX, and it's going to be a difficult schedule to build, integrate, and test this new engine in the Antares within a year, and they're going to need to prove to NASA that they can launch reliably before they're willing to strap another space station delivery onto the rocket. And Antares needs to show that they're reliable too, because if they have another accident like the one that happened last week, that's going to put them in an even more serious position moving forward.
Yeah, no, this is, I'm sure they're putting the best spin they can, the best face on it they can, but they've got their work cut out for them, and a lot of things have to go right. Just to step away from a motor which has worked for them flawlessly for all this time and had one accident, I think was a pretty big decision. And I suspect it was probably caused by some of the political implications of buying Russian rockets.
Yeah, they were already planning to make this transition. They were just going to ease into it in 2017, 2018, and beyond. And they're undergoing the same process that the United Launch Alliance with Boeing and Lockheed are doing at the same time right now, which is trying to divest ourselves of dependence on Russian engines in order to, build our American and European space delivery systems. And so this is going to be a good thing in the end. It's just a question of whether or not they can do it and still fulfill their contractual obligations.
Yeah, and I think it would be great to have a proper competitive landscape that they're, I don't want SpaceX to run away with this.
We want Orbital to succeed. That we need them.
We want Orbital, exactly. That's exactly right. Which is, I am absolutely rooting for Orbital to get these these problems under control, get these new motors running, get them tested, and get a nice, proper, healthy, competitive environment. That they are already a very entrepreneurial, very forward-thinking company. A lot more streamlined than some of the bigger, the sort of the older and more established aerospace firms, and like SpaceX, bring a lot of sort of new energy to this challenge, and so it'd be great for them to solve it. So yeah, absolutely. So let's move on then. We got one last story from you, Dr. Koberlein, and then we'll move on to the WSHE crew stories. Oh, we'll answer some questions too, but let's get on to your next story.
Okay, so this is an alternative idea for dark matter, because if you know the whole story about dark matter, we've got lots of evidence to support it, but we keep not finding dark matter particles. And this is becoming problematic. So this is a new paper out that looks at it a little bit differently. Most of the dark matter particles that we talk about are what are known as WIMPs, or weakly interacting massive particles. So they're more massive than protons, and they interact through the weak nuclear force, which is why they don't interact strongly with light. And that's largely, and that's kind of the dominant model for where we're looking at things. So this proposes a different model, which is maybe they're a lot lighter, but they're strongly interacting amongst themselves. And so it's a similar analogy to quarks, where you have quarks that can combine really strongly to themselves, and therefore they clump into heavier particles. So the idea here is that you have these strongly interacting particles that would tend to clump into what would seem like more massive particles. Now, if you do the right kind of mathematical just so story, then you can make it look very similar to WIMPs. They can look more like traditional dark matter particles, except that they're lighter and they clump. In the paper, they look at how what the observational limits are on that, and so it allows for them to possibly work. But the one thing it gives you is it would explain why we haven't detected these types of particles yet. And that is because on the individual level, they would interact more with electrons than they would with nuclei. And we've been looking for nuclei interactions because the WIMPs would be heavy particles. They would interact more strongly with nuclei. And we haven't found that. So if these lighter particles clump, they would actually interact more strongly with electrons, which would then explain why we don't see these particles. It's an interesting idea. It has a little bit of a flavor of a just so story, but they are looking at, if this works, these are the observational limits on it. So they're very careful to show where the observational limits are and where we could go next to try and distinguish this from other particles.
Now, is an experiment like the Large Hadron Collider capable of testing these electron interactions?
This is one of the things that they have to kind of account for, because the lighter particles, you would expect lighter particles to show up in the Large Hadron Collider, and they haven't. So they have some kind of arguments as to why they wouldn't yet, but again, there would be experiments coming in the new version where they would be able to see things. So they're kind of like, they toss this out here and it's just above detection, but the next generation of detectors, both of dark matter and of particle accelerators, would detect these. So, they're cautious about what the results are, but, they may have some big success in the next generation, or they may be disproven in the next generation. So that
sounds like they're doing it perfectly according to procedure. This all sounds fine.
It's good work. It's interesting. It's not really strong enough to make everybody discard WIMPs yet, but it is an interesting idea, and it's the type of thing we need. We need more wild ideas tossed out there that are still clung to the evidence, where we can say, look, maybe it's this, maybe it's that, maybe it's these other things, because the more we toss out there, the more we can kind of, as we're running out of options, we can come up with new options that might be there.
Yeah. Awesome. Okay, so I've got a few questions I wanted to hit you guys with first before we move on to the other stories. So this comes from Rashan Bakari. Can Alma look at objects closer than this star? Could it look at planets?
I don't know much about Alma's planetary usage, if submillimeter is actually useful for planets in our solar system. As far as for systems like this that are forming, pretty sure the Taurus region is one of the closest of these types of systems, and so they went for the closest, the easiest to find. What they can then use is that to extrapolate out to further ones where we won't get as good of an image just because of distance. But I'm not sure about planets in our own solar system.
Ben Gaisley asks, could some of those inner lanes be cleared out by residents from planets forming further out?
Yes.
That's a possibility, absolutely.
Very much so.
Yeah, we can't tell where the planets are.
Can you explain that, Morgan, just to sort of give people an idea of what that question's about?
Yeah, so we see these actually all over our solar system, both in rings of all the outer planets, but also in the asteroid belt. And what happens is that the farther away you go from whatever you're orbiting, whether that's the Sun or Saturn or this protostar, the slower you orbit. And that's just a result of what are called Kepler's laws. Basically, gravity's pulling you less hard, so you're going less quickly. And so you can imagine there are places within a disk system, take this protoplanetary disk, where particles on the inside are going around twice for every trip a large body, like say a forming planet, goes around. And when that happens, they line up pretty frequently, once every 2 orbits of those particles. And that means that they get a nice strong gravitational tug every 2 times around, and that tends to pull them out. And that clears out these gaps that we see. We see them in Saturn's rings. We see them in what are called the Kirkwood gaps in the asteroid belt. There are these places in the asteroid belt where there mysteriously are no asteroids. And we realize that this is happening because we have one of these resonances with Jupiter. The asteroids go around 5 times for every 2 times that Jupiter goes around. They line up, they get tugged away, and it clears out this area. And so it's not a surprise at all that we see this in protoplanetary systems as well.
Mm-hmm.
They could reveal planets that we can't actually see because the planet's too small, but their gravitational effect should tell us that maybe there's a planet out there, and it helps us narrow down basically where we need to search.
Mm-hmm.
And I wanted to make one quick comment on planetary science with Alma. There is a workshop happening in March for planetary scientists using various telescopes, including Alma itself. So if you're a planetary science person, looks like their abstract deadline is coming up the end of the month.
So Nancy Graziano asks about the Antares. Do you think there would have been as much controversy over the use of Russian rockets had there not been the failure earlier this year? So I guess that was there was a failure of a Russian rocket, right?
I think the controversy is not having to do with the reliability in terms of actually functioning on the launch pad. It's the reliability of procuring them. And with with the various
tendency to invade neighboring nations,
geopolitical
with you.
Considerations, then it's possible that Russia could choose to withhold those as a strategic action, basically, against Western countries.
Yeah, it's a political move because you can now use that to exert pressure on the company to switch over.
Did you like my Putin?
So Elad Avron asks, back to the protoplanetary, that image is incredible. Do we know anything about those planets or those future planets other than their orbits?
Nothing.
And possible size? We don't even know their possible size yet.
Not yet. The computing guys are going to do something with it. I guarantee you.
Oh, the theoretical? Yeah.
Yeah, they're going to look at that. We can model this.
Yep. Yeah, but that's the best we can do is make guesses and actually study the disk material that is there.
Right.
Elad also asks, do we expect dark matter to behave or appear similarly to antimatter? We would see it exploding, right? If it was behaving like antimatter, wouldn't we?
Yeah, I mean, antimatter is still regular matter. Antimatter still interacts strongly with light, so it's not a way to get out of it.
Okay, let's move on. So we're going to bring up some stories, and these are stories that were sort of collected in the WSH Crew Google Plus community over the course of this week. And again, I've mentioned this. I highly recommend, if you are a fan of the show, if you're a fan of space and you want to just talk to other super diehard space fans, I highly recommend joining this community. So this comes from Nicole Best. And that is that Space Oddity's back. So after a brief license conversation, Commander Hadfield's space-based rendition of Bowie's Cosmic Oddity is back on the YouTubes. Have we all watched and just loved this?
Yes, and I made a point. I turned it up and I was singing along, and my office mate through the wall and Learning Space co-host Georgia Bracey just kind of comes around and looks at my door like, "What are you doing?" And I'm like, "Hadfield's putting the video on!" So that was my introduction to having it back on YouTube.
Yeah, and so if you go to Chris Hadfield's website, there's sort of a story about what it took to bring this back, and it seems a little politically correct the way it's been written. So if you read it, it's like, well,
What do you?
straightening out the copyright license is a very long affair, and it took us a while, and all the ducks had to be put in place, and so on and so forth. But it sounds like, if you read between the lines, lawyers got mad, people had to demonstrate the public relations positiveness of letting it stay, and it's back. So yay!
Say whoever had the decision-making power are not space geeks. Maybe.
Yeah. But in the end, good call. This will be nothing but good for Bowie's career.
Although I don't think he has. Bowie doesn't hold the copyright to the song, right?
Oh well, there's the problem.
It's somebody else. Yeah.
But anyway, whoever decided this, you're going to make boatloads of money. Don't worry. Just check your iTunes downloads revenue. It's going to go up right now. So, all right, let's move on. So this story comes from. We don't know who it came from. Oh no, there we go. Jim Meeker. And this is a NASA rocket experiment, The Universe is Brighter Than We Thought. So a rocket-based observatory has returned hundreds of images of space, and based on this, astronomers were able to deduce that the universe is brighter than it's supposed to be. So you had seen this, Brian?
A little bit, yeah. Basically, there's always this background light in the universe, and part of it's from the cosmic microwave background, part of it's from distant galaxies, part of it's from gas and dust and everything else. And if you look at the distribution of matter, you can get a kind of basic idea of what's out there. So they did a background survey of all these different images and calculated what the background was, specifically in the infrared. And they found they got a stronger infrared signal than they would expect. Now, one of the possibilities of that is that there's actually more galaxies really, really, really far out than we would expect, which would give kind of a background infrared signal. But this particular signal actually increases as you move towards what they call the blue, but I would say less infrared. So as you get more close to the visible spectrum, the amount of brightness starts going up. And that isn't what you would expect with distant galaxies. You'd expect it to kind of die off. And so the idea they have here is that it could be due to very faint background stars that are not part of galaxies. So they're not as far as the distant galaxies, but they're just kind of rogue stars out there. And they're too far for us to see directly, but they still contribute to the kind of overall brightness of the universe. And so it seems to be evidence of a whole bunch of rogue stars out there.
And how do these rogue stars get out there?
Well, I mean, they could form out there, but probably a lot of them are from galactic interactions where they get thrown out.
You could call them cosmic castaways.
They could be cosmic castaways.
Show about those stars. Partially put out by CosmoQuest.
Yeah.
Where can we see this this thrilling planetarium show?
It's on YouTube. It's put out by the Ward Beecher Planetarium. There's a flat version on YouTube, but they've also put out the dome version for Creative Commons. So you go to CosmoQuest, look for Science on the Half Sphere, and you'll find the contact information.
And who does the voiceover, I wonder?
Gigantic. Who do you think does the voiceover? It could be our very own Pamela Gay.
That's awesome.
It's a really cool 20-minute show. You can show the video in your classroom, or you can get the Dome Masters for your planetarium for free.
All right, so this also comes from
name.
This also comes from Jim Meeker, but it also came from a bunch of people as well. And this is that Philae's Descent and Touchdown timeline is going to be happening between now and the next episode of the Weekly Space Hangout. So, Morgan, how is this all going to happen over the next week?
Yeah, so Touchdown is scheduled for sort of evening time here in the United States on November 12th, which means that on November 11th, they'll begin preparing for this tricky operation. They're going to have power up everything on Philae that isn't powered up now. They need to heat the batteries on Philae and charge them up so they can disconnect basically from the main Rosetta. mothership, and then on the 12th it'll disconnect and sort of begin drifting towards the comet. And if you're kind of imagining the Curiosity 7 Minutes of Terror kind of thing, this is going to be the opposite. This is going to be 2001, a comet landing odyssey. And it's just going to float ever so slightly across.
I'm sure it's a bit terrifying for the actual flight engineer.
And eventually it will hopefully touch down, and they will be able to attach the harpoon-type mechanism that will latch it onto the surface. And from that point, then, they will be able to begin figuring out where they are. And hopefully they're upright and operating, and then we'll be able to start getting back pictures from the surface of a comet for the very first time. And that'll be very exciting.
That's fantastic. So give people the exact time when they should start their Rosetta party.
All right.
And then when they could expect to have it finished. They need to plan how much beverages and food they're going to need.
Okay, I'll see if I can find.
I know Emily
exact time.
blagged. She blagged.
So the expected landing is at 5:02, but I have no idea what time zone that is.
Well,
And that's the Earth receive time. There's about a 10-minute light time delay between Rosetta and.
It's probably in Germany.
Yes, probably because this is an ESA mission.
Yeah.
So it's going to be about midnight here in the United States, in North America, depending on where you are in the country. And it corresponds very nicely with a giant meeting of planetary scientists in Tucson, where we'll be gathering to watch this and then wake up in the morning and talk about it.
So someone suggested we should do live coverage of it, but that sounds really slow, and we'd be like when we did the coverage of the Venus transit, and we just went on and on and on, hours and hours.
I was enjoying sitting in the sun. I don't know about you guys. I had my big floppy hat for that event.
But the Curiosity one was an hour in and out, done. Well, we went for about 3 hours, but it was great.
So the Emily Lakdawalla has a blog post about it at planetary.org with a really detailed timeline, and it has the time in Central European, UTC, and Pacific Standard. So you should be able to figure out your time pretty easily from there. The expected landing looks like it's going to be 8 a.m. Pacific Standard for those of us in the U.S. So at 5 p.m. Central European, 1600 or 4 p.m. UT.
On the 12th.
Oh, so it's early. Okay.
So it'll
the
actually
morning of the 12th. Yeah.
For us. Although we're not doing a live thing, since our Learning Space is typically scheduled on Wednesdays, we've decided to make Learning Space that day Rosetta themed. We'll update you with all the news that's been happening and talk about some comet-related educational activities and classroom lesson plans. So Learning Space will be Rosetta themed later that day.
Awesome. Okay, so and then the last story is sort of related to what we're talking about, and I guess just want to say that to the planetary disk, this comes from Helga Bjerkog. Hubble surveys debris-strewn exoplanetary construction yards, and the gist is that Alma wasn't the only observatory looking at this protoplanetary disk. Hubble Space Telescope got into the action as well.
Well, there's two images. One of them is an image of the star of HL Tauri and some of its neighboring stars that are young and forming from Hubble. That came out the same day to kind of like show a comparison of here's what Hubble is seeing. So this
Hubble gotcha, Alma.
Yeah, no, not as nice. Look at that little dot. Look at the little dot. So that's HL Tau, and so it's actually looking at the bigger picture at the jets of material called Herbig Haro objects coming from the forming star. XZ Tau is giving off this bubble of junk, basically, coming from the forming star. And then there's another forming star down here, which it has another pair of jets that Hubble saw. So it's seeing the system a little differently. The other one from Hubble, these are debris disks. This, I think, was the story
yes.
too. These are, Hubble recently did a visible light survey of debris disks, which is a stage that's a little bit later than what we saw in the Alma picture. This is dust and stuff left over basically during the heavy bombardment stages of the solar system. Most of your planets are there, but they're still getting whacked by a lot of the extra rocks, asteroids, comets, whatever is left over from building that system. And what they've found is that, as you can see from this sampling, debris disks are not all the same. They're not these flat pancakes. Some are curved, some have lumps, based on the planetary motions happening in the system or nearby passage of another star that can affect quite greatly what these debris disks look like. So this is, again, early solar system, but not quite as early as I think we saw in the Alma image.
Mm-hmm.
Those black circles are the outline of the Hubble coronagraph, blocking the light of the central star.
Right, right.
Yeah.
So that's just kind of putting your hand in front of a light bulb so you can see what's going on around it.
All right. Well, why don't we wrap things up then? So let's give folks a chance to shamelessly self-promote the things they do. So, Brian Koberlein, where do we find out more about you, and what are you working on?
Well, you can find me on my blog, which is One Universe at a Time, at briankoberlein.com. You can find me on Twitter at Brian Koberlein. You can find me on Google+. I'm still doing daily posts, and so if you want to support me, you can support me on Patreon. I crossed a threshold, so I do have a podcast.
Right
episode
on.
1 that's coming out, but yeah.
Nice.
So that's what I'm working on.
Let me know if you ever need a guest. Nicole will be glad to be on the show.
Okay.
Morgan.
Yeah, well, right after the show, you can find me over on the Google Plus Space community, talking about all of this week's stories, any questions you might have, and maybe a bit about what I thought of Interstellar, since apparently we're not allowed to talk about it on the show.
What did you think?
And
Did you love it? Did you love it with my buddy Anne Hathaway? No.
I did not particularly like it.
Phil savaged it.
It was. I didn't think it was as bad as Phil did, but I did not think it was particularly good.
That hurts me because we have similar tastes. I was really looking forward to this movie.
Gravity was a much better film.
Yeah, he just really came down on it pretty hard. Okay, so we can find you in the Google Plus Space community. Your website?
Yep, you can find me at cosmicchatter.org, and you can find me on Twitter at Morgan Rehnberg.
Awesome. Dr. Noisy, where do we find out more?
After this hangout, you can find me setting up my classroom for 8 a.m. on Monday.
What will we be learning?
We will be learning about conservation of energy. Conservation of energy on Monday. So
nice.
I'll be teaching my elementary ed major. So I'm teaching at Southern Illinois University, Edwardsville. I work for CosmoQuest, doing a lot of the social media promotion and some of the education research. And I also work for Gateway Teen Science Cafe, the St. Louis teen cafe where scientists come and talk to teens about what they do and how they got to the careers that they're in. And my website is Noisy Astronomer. I have real high aspirations of posting there more often because it's been a rough semester. So, yep, that's me.
All right, and of course I'm the publisher of Universe Today. You can check that out at universetoday.com. You can follow me on Twitter right there. You can follow me on Google+. I highly recommend our Instagram page. It's pretty great. So it's Universe Today on Instagram.
If you want to see pictures of my dog, you should follow my Instagram page.
Really? Have we all got Instagrams?
It's basically all pictures of my dog right now because I just got a dog.
Ours is pictures of space. So,
yes.
There's that. So we and a bunch more videos out on YouTube. I think one written by Brian this week, actually. It's coming out. So,
cool.
But we put it in the credits when the ones are written by Brian as opposed to the ones that are written by me. So, thanks everyone for joining us this week. Really appreciate it. Another reminder, go and check out the WSH Crew community on Google+. It really is the partner to this entire show, and we really couldn't do this without their efforts every week. So we really appreciate it. So go join their community and participate in the fun. All right. Well, thanks everyone, and we'll see you all next week.
Okay.